Hello guys and welcome to Mossy Maths in what is the final lesson on the topic of simultaneous equations and also the final lesson of Core 1 AS Maths. And after this I'll be moving on to the second unit of AS Maths, which is Core 2. Now for the final lesson of simultaneous equations, we're looking at how we can use the method of substitution to solve a simultaneous equation where one is a quadratic or in the form of a quadratic. And the method we use for this is consistent with these types of question, and although this is more difficult than the first lesson, we are looking at 3 or more marks in an exam, and I wouldn't say it's the most difficult topic of Core 1, so really we should be aiming for full marks on any of these types of question. And the method we use is as follows. We first isolate the variable in the linear equation. The linear equation is the one without the x squareds or y squareds, and by isolate I mean make it in the form x equals or y equals. We make either x or y the subject of the equation, and then we substitute that into the quadratic equation. After that we solve to get the values for one variable, and then we stick these values into the linear equation to get our final answer. So, let's get started with the first question. Solve the simultaneous equations minus x plus 2y is 5 and x squared plus y squared is 25. So, firstly we isolate a variable. I'm going to pick x. I'm going to make it in the form x equals. So to do that, we can firstly move the x across to get 2y equals 5. Now this minus x will become plus x. Now we can move the positive 5 across to become a negative 5, so we just have x on this side. X equals 2y. Now this positive 5 is going to become a minus 5. So x is the same as 2y, minus 5. X is 2y minus 5, okay? So, what does this mean? Well, it means if x is this, then x squared is also this squared. So we can actually substitute this into the quadratic equation so that we can solve then for y. If x is 2y minus 5, then x squared is the same as 2y minus 5 squared, which you can write as 2y minus 5 times 2y minus 5. So how do we expand the brackets with this? Well, we do 2y times 2y, which is 4y squared. 2y times minus 5 is minus 10y. We're going to get 2 of these, so we're going to get minus 10y, which is minus 20y. Minus 5 times minus 5 is positive 25. Now we rewrite this. So we get 4y squared minus 20y plus 25. Don't forget the plus y squared, and this equals 25, okay? Now, we can simplify this down. 4y squared add just the 1y squared is 5y squared, minus 20y, now positive 25. Whenever we solve a quadratic, we want to get it in the form equals 0. So to get rid of the 25 on this side, we need to subtract 25 from this side. But we already have a 25. So 25 subtract 25 just gives us 0 as a constant term on this side, and that will equal 0. Now, we need to factorise this, and the way we do that is by taking out a factor of y. And we can take out 5y because 5 goes into both 5 and 20. So how do we get 5y squared by multiplying by 5y? Well, we just have 1y in the brackets. Y times 5y is 5y squared. How do we make the minus 20y? Well, we minus 4 inside the brackets. Minus 4 times 5y is minus 20y, and this equals 0. So we now make each part equal to 0 to get our y values. If we make the 5y equal 0, then we just end up getting y equals 0. Okay? If 5y is 0, then 1y is 0. And if the y minus 4 is 0, then we get y equals 4, just moving the negative 4 across the equal sign. So we have y is 0 and y is 4 as our two possible y coordinates. Now we need to find the x values when y is both of these. So let's consider when y is 0. And we substitute into the linear equation as it says here because it's a lot easier. We could use this, but the linear equation is normally simpler. So if y is 0, minus x plus 2 times y. Well, y is 0, so minus x plus 2 times 0 is just minus x on this side of the equation. So we get minus x equals 5. If minus x is 5, then we just swap the signs to get positive x. X equals minus 5, okay? Just swapping the signs of both. So when y is 0, x is minus 5. As a coordinate, we write it like this. Now let's consider when y is 4, which is our other possible value of y. If y is 4, then minus x plus 2 times y, well 2 times 4 is 8, equals 5. Minus x plus 8 is 5. So 5 minus 8 will give us minus x equals. 5 minus 8 is minus 3. So we get minus x equals minus 3. If minus x is minus 3, then x is just positive 3. And now the coordinate associated with this would be 3 as our x value and 4 as our y value. So there are two coordinates. So we've solved the simultaneous equations. When x is 3, y is 4, and when x is minus 5, y is 0. So that would pick us 4 marks up, and we're likely to get around 4 marks in an exam. But what does this mean in the context of the question? Well, hopefully we've noticed that this equation here is actually the equation of a circle with centre 0, 0. If you go back to my topic on circles, then you'll realise this is just a circle with centre 0, 0. So you will realise now why we get two coordinates of intersection. It's because if we have a circle, which will go through, well, if this is our r squared, then r is the square root of 25, which is both 5 and minus 5. So it will go through 5, minus 5, 5 and minus 5 on both the y and x axis. So if we have a circle that maybe looks a little bit better than that, but if we draw the circle and we have a line, so this isn't going to be accurate to how it would be in reality, but just say the line looked like that, you can see we're going to get 2 points of intersection with the circle. So that's why we have two coordinates. Okay? So, let's move on to the second example. Find any points of intersection of y equals x squared minus 4x plus 5 and y equals 2x minus 4. With this one I'd like you to have a go at home. Just pause the video, have a go, and I'll go through the answer with you straight afterwards, okay? Okay guys, hopefully you've paused the video and had a go yourself, so I'm going to go straight through this one. So, we already have this in the form y equals, okay? We don't need to isolate a variable, either x or y, because it's already isolated for us. So we can just use y equals 2x minus 4. If y is 2x minus 4, then using that as y here, we get 2x minus 4 equals x squared minus 4x plus 5. Okay? Because y is this. Well, moving the 2x across, we get minus 4 equals x squared. Now minus 4x, this is going to become minus 2x. Minus 4 minus 2x is minus 6x plus 5. And finally we get this in the form where it equals 0. So we can solve it using factorisation. So we get x squared minus 6x now plus 5. This minus 4 is going to become a positive 4 when we move it across. Positive 4 plus 5 is positive 9. And this equals 0. Now we can solve it by factorising. And we're just going to get, well, minus 3 times minus 3 will give us positive 9, and minus 3 add to give us minus 6. So it's just x minus 3 when we factorise. Or we could write this as x minus 3 squared. Okay? So if we've got two brackets which are the same, then we just have two values which are x equals 3. Making both brackets equal to 0, then x is just 3 for both. And this is a quadratic. So what does this look like? Now, again, I'm not going to draw it accurately, but I'm going to show you what sort of thing we're going to get on a graph. Because with the quadratic, y equals x squared minus 4x plus 5, well, that's just a parabola with a positive coefficient of x squared. So it's going to have a U shape. It's going to look possibly something like this. It could look like that. and the line y equals 2x minus 4, well, we've only got one value of x where it intersects the parabola. So it can't go like that, or it can't go like that through the parabola. It has to touch the parabola at this one point, x is 3. So if we say this is the point x is 3, then it would just be a line that touches the parabola where x is 3. Okay? So that's all we're going to get. It's a tangent. What we're getting is a tangent to the curve. Okay? So that's just showing you what we're going to get. Now, to finish this question off, we need to find out the value of y when x is 3, okay, to get our coordinate at the point of intersection. So to do that, we substitute 3 into either. I would use a linear equation. So y equals 2 times 3, okay, 2 times x. So y equals 3 times 2, that's 6, minus 4. Therefore, y is 2. So when x is 3, y is 2. And that's the coordinate at the point of intersection. So in reality, this graph would look slightly different. The line would move up 2, okay, on the y-axis. But that's just the idea of what's going on, okay? We have a tangent. That's why we only have one value of x. So, we've now found the coordinates of both and we've solved both equations. So this is how we solve simultaneous equations when we have one which is a quadratic. And it's not unusual to get an answer where we have only one x value like this, where x is just positive 3, for example. We could get that because it's a tangent, and we could have a line which is tangent to a curve, and technically they still intersect at this one point. So don't expect, if we have a quadratic and a linear equation, don't expect there's going to be two different coordinates, because it's not necessarily the case. So there we go, guys, that's the final lesson on the topic of simultaneous equations. If you found the video helpful, please leave a like. If you have any comments, please share them and I'll try and get back to you as quick as possible. And this is the final lesson on Core 1AS Maths.